Let's do a few more examples of some radical equations. This time we're going to be looking at some examples that have two radicals in the equation. All right, so let's take a look at this first one here. Here we have the square root of 7u plus 6 is equal to the square root of 5u plus 16. Okay, so nothing really changes here in terms of our basic goal. Really what we're going to want to do is we're going to go ahead and square both sides to get rid of these radicals here, okay? But just like in our previous examples, anytime you square anything, we're going to have to go back and check that our solution actually makes sense, okay? So, knowing that though, let's go ahead and note that squaring both sides is actually going to make these radicals just disappear. So this equation is actually just going to become 7u plus 6 is equal to 5u plus 16. Okay, so now let's see if we can isolate our variable on one side and our constant on the constants on the other. So let's take 5u away here. Okay, and so we'll end up with 7u, or I guess in this case it'll be 2u plus 6 is equal to 16. And now we can take 6 away from both sides. Okay, and we'll end up with 2u is equal to 10. We can divide both sides by 2. These 2's will cancel, and we'll get u is equal to 5. Okay, but we have to check that this actually makes sense. All right, so if it makes sense, we should get something that is equal on both sides. All right, so we had 7u, the square root of 7u plus 6. So we'll have the square root of 7 times 5 plus 6 should be equal to the square root of 5 times 5 plus 16. Okay, so here we have 7 times 5, which is 35, plus 6, that should be 41. So we have the square root of 41 is equal to 5 times 5 is 25, plus 16 is also 41. So we have the square root of 41 is equal to the square root of 41. I'd say that makes sense. So we can go ahead and say that u is equal to 5, and that is our solution for this equation. Okay, how about this one? We have the square root of 2u plus 15 minus the square root of 4u plus 7 is equal to 0. In this case, it's a pretty easy way to make this into a similar form of what we've just seen. Let's go ahead and add this whole thing, the square root of 4u plus 7, to both sides of the equation. Okay, this will cancel, and we'll get that the square root of 2u plus 15 is equal to the square root of 4u plus 7. And we solve by squaring, just like we did last time. So now we have 2u plus 15 is equal to 4u plus 7. Okay. To avoid negatives, I'm going to bring this 2u from this side over here. And we'll get 15 is equal to 2u plus 7. And now we can subtract 7 from both sides. And we're going to get that 8 is equal to 2u, where we can divide by 2 on both sides, and we'll get that u is equal to 4. Now, if this is true, then we should be able to plug it back into our initial equation, and that should make sense. Okay, so let's go ahead and check our answer. All right, so we should have the square root of 2 times 4 plus 15 minus the square root of 4 times 4 plus 7. This should be equal to 0, if this is correct. So here we have 2 times 4 is 8. 8 plus 15 will give us the square root of 23 minus 4 times 4 is 16, plus 7, that is 23 again. So the square root of 23 minus the square root of 23 is equal to 0. Again, I would say that this is true. So we can go ahead and assume that u equals 4 is a valid solution.